Okay, so 5-5 absolute value. There are lots of relationships. There's a reason why we spend a whole term on quadratics. Because there's... Put that phone away, please, AJ. Similarities and differences. But there are lots of similarities of absolute values and all the other functions we do to quadratics. So our central question is, what are similarities and differences between graphing a quadratic function versus an absolute value function? Okay, we're going to start this the same way we start with circles. With circles, we start talking about vertex form of a quadratic. Okay, does anyone remember vertex form of a quadratic? Y equals, there's an A, parenthesis, X, minus, H, thank you, all squared, not Y, plus K. There we go. Does that look familiar? Okay, in quadratics, the A's do a special thing. It affects the steepness of the graph. You can also flip it if it's negative. What does the minus H do to the graph? H also starts with an H, horizontal shift. And the K is vertical shift. So the reason we're writing this quadratic again is because it has the same relationship with the circles. If it's within the function, if it's in the grouping, we always think opposite. So these parentheses group the X, the horizontal shift, we always think opposite. If it's outside of the function, because the function is squared, after the squared, there could be an extra number, +7 or -3. That K is a vertical shift, and it's outside the function, so we say same. But the idea today, and last time with circles, if it's within the grouping, we always have to think opposite. Okay, so for an absolute value, standard form of absolute value is the following. Standard form of absolute value is Y equals A. What is an absolute value sign? Yeah, those straight bars, jail cells. Now make sure your bars are tall enough and long enough that they don't look like ones. X minus H, close up the absolute value, plus K. Does that look similar? Yes. Yes, it does. What are some similarities? I promise you, those look the same. Pretty close. They both have an A. Let's talk about what A does. What happens when A, the multiplier, is greater than 1? The multiplier acts like a slope. Affects the steepness of the graph. So what's a number greater than 1? 2, which is the fraction 2 over 1. So if I go up 2 over 1, up 2 over 1, up 2 over 1, am I getting... What are the arms doing? Are they steep or are they less steep? They're steep. So as we increase, we get steeper. Same thing for quadratic. I'm going to actually put the absolute value of that because the same would happen if it was negative. Okay, what if A, our multiplier, is a fraction between 0 and 1? What's a fraction between 0 and 1? 1/2. So we go up 1, out 2, up 1, out 2, up 1, out 2. Am I getting steeper? What are the arms of the... Making wider. It'll be less steep or wider. And then the last thing A can do is if A is negative. If A is less than 0, just like a quadratic, if it's negative, what happens to the graph? It flips. Okay, AJ, I really want you to put that phone away. All right. Any ideas what this H does inside the grouping? It's horizontal shift. It's the same. And the K? Vertical shift. And guess what? The grouping, this time is absolute value, but it's within the function, the absolute value function, so that has to be opposite. After the function's ended, if we have an additional plus K, that's same. So whenever you see it within a grouping, that's opposite. Okay? Let's get rulers. Now, rules with rulers. There are only two things you should be doing with these. And one of them is not writing things on them. I'm going to pass that one out. Two things to do with rulers. You measure things, and you draw straight lines with them. That is it. If you're doing something else that's not one of those, please stop. Do not spin them. Do not spin them on the tip of your pencil or pen. Please do not hit each other. Please do not slap each other. Please do not do anything else like that. Alrighty, we're going to first look at the parent function absolute value to see the shape of an absolute value. So example, actually, sorry, I wanted to review this first. Example 1, really quick, no spinning, take your pencils off that. Colby, what is the absolute value of 3? No, that's squaring. What's the absolute value of 3? No, 3. Absolute value means the distance from 0. The number 3 is 3 units away from 0. Distance always has to be measured in positive units because length can't be negative. So what would the absolute value of negative 3? You got to make those bars nice and long, otherwise they can look like 1s and you get confused. Because is negative 3 also 3 units away? So they have the same, don't spin please. They have the same absolute value. Okay, this is the parent function. Meaning the most basic way we could see an absolute value function. Y equals absolute value x. Okay, so we're going to graph this. And we're looking to see the shape an absolute value looks like. Okay, let's use negative 2 to positive 2. So do an XY table to get some points. Negative 2 to positive 2. You could do a horizontal XY table. I generally do a vertical one, but whichever works. Okay, and then we need a room for work. Justin, what is the absolute value of negative 2? Great. Okay, AJ, what about the next one? Absolute value of negative 1? Yep, because it's always positive except for this guy. What's the absolute value of 0?
0.
0. So 0 is neither positive or negative, but 0 is 0 units away from itself, so it's 0. Absolute value of 1?
1.
Interesting. Absolute value of 2? Oh, interesting. Do you notice anything here?
Pattern.
Pattern. We have something around 0, 0. There's an S word for it. Symmetry. You should have some symmetry. Okay, so let's get our rulers and set up the graph. Looks like we have nothing larger or smaller than negative 2 to positive 2. So would you draw an X and Y axis, taking all quadrants out to negative 2 and positive 2? You have rulers, so that it will be nice and straight and neat. Please label with numbers. No, medium size is fine. Okay, and plot the 5 points we found. We're looking for what shape an absolute value looks like. Yep, that'll be fine. Okay, and label them. Dylan, you have them all labeled? What shape did you get? It's starting to take form of... It's not a square. Definitely not a square. Nope. This is a function. So vertical line test has to pass. Okay, seriously? It's not going to be a spiral. No. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. Oh, it's a V. That's what it is. Okay, it's different than the quadratic, because the quadratic slope was constantly changing, which is why it was curved. But you can see on each of these, we go up 1, right 1, up 1. I missed out a little bit. A little too high. Up 1, right 1. The slope is constant, so each arm is linear. This side of the arm has a negative slope, so it needs to be straight, like a V. This side of the arm has a positive slope. Okay, so it needs to be straight. Quadratics need to be curved like a U. A parabola is curved. Versus absolute value has a V in it. Absolute value looks like a V. Okay? All right, we are going to, I'm going to give you a harder one, for example 3, and we're going to figure out how to graph it. Finding, you always want to graph around the center. So just like quadratics, we have a nice vertex in the center. So we'll find the vertex, doing opposite same, and be good. And graph it. So y equals negative 2 absolute value, x minus 3 absolute value plus 1. Y equals negative 2 absolute value, x minus 3, close the absolute value, plus 1. You need to make sure you have distinct points on your graph. It needs to be very specific. That looks lovely. Okay? We need to find the center of the graph. We can do that if we understand how absolute values are written. Mikro, what type of shift is this? What type of shift is this? And what's the saying for this? What's the saying if it's inside? What's opposite? It's outside the function. They were all trying to throw you off. Same. That is our vertex. It works the same way as quadratics. So if we're looking for the center of our graph, we have a horizontal shift here. We have a vertical shift there. We do opposite, same. So we're going to need to get some points. This one takes a little more room for work. We'll put our vertex in the middle. Opposite, same. Colby, opposite, same. What's the vertex? Opposite this number. What's the vertex? Opposite. What number would that be? Same. So 3, comma. Okay, and put that in the middle. That's the vertex, and we should have symmetry around the vertex. I'm going to choose a couple x's smaller. Maria, what are a couple x's smaller, right, in order from 3? And then, great, and a couple bigger? Thank you. Write it down. Okay, now we need to do a little work off to the side. And the good news is we actually only have to do work twice. As long as we do it carefully and correctly, because of symmetry, we only have to find these two, and we can use symmetry to write the other two. So we're going to plug in 1 where the x was. Negative 2 absolute value, 1 minus 3, close the absolute value, plus 1. Now, absolute values, even though they don't look like parentheses, they're still in the family of parentheses. When we talk about, please excuse my dear Aunt Sally, parentheses is just in the placeholder of a grouping. So this is a grouping. We have to do the grouping first. So we have to do 1 minus 3 first, which is what? Negative 2. Yep. So negative 2 absolute value, negative 2 plus 1. Okay. Next, we actually have to take the absolute value. So Isabel, what's the absolute value of negative 2? Good. So this is being times to the other negative 2. So it's negative 2 times the absolute value, which is positive 2, plus 1. Which comes next? Do we add or multiply? Multiply. Negative 2 times 2 is, negative 4. Plus 1 gives us negative 3. So that is my y. I found 1 point. We have to do work one more time. If we do it carefully, then I can just skip the work and fill them in down here. What's so exciting, guys? Do you see this orange? All right. So we just, instead of the 1, we replace the x position with the next one, 2. I don't think Colby can see it. Or, not Colby. Stetson, sorry. I'll change it. Sorry, just slipped. Negative 2, absolute value, 2 minus 3, plus 1. Okay, Miklo, do it for me, please. What do I need to do first? Please excuse my dear, I'm sorry. Please, parentheses means grouping. Is there anything grouped? Yep, grouping. What is 2 minus 3?
Negative 1.
Okay. Now what? We have timesing, we have absolute value, and we have add. What should we do first?
Add.
There's not even a subtract. You need to do the absolute value in order to 2 times. Absolute value. You're still within the grouping. What is the absolute value of negative 1? No. Don't listen to them. They're just making your life awful. What is the, how far away from 0 is negative 1? Because that's what absolute value means. It's 1. Negative 2 times 1 plus 1. Almost done, Miko. Don't listen to anything they say. Do we multiply or add first? Times. That's good. What is negative 2 times 1? Okay, and then add the 1 and we have our answer. Good. Okay. For torturing for Miklo, Colby, what is the y value here using symmetry? What? Using symmetry, what is the y value? Nope. Symmetry. Negative 1. And what's this one? Colby? Negative 3. Because they should be matching. We should have a repeated pattern. Okay, if I look at, you should always be looking at what you're graphing before you start setting it up. I have up to positive 5. I have down to negative 3. So I'm going to take all my axes to negative 3 and positive 5. Draw your graphs, please. On the negative side, we don't need too much. The positive side, we need a little bit more. 1, 2, negative 3. 1, 2, 3, 4. Try to evenly space them. Pick your ruler and draw a graph, please. 1, 2, negative 3. 1, 2, 3, 4. Ooh, barely made that one. Why? Plot the points. Make sure it looks like a V. If you don't get a V, you've done something wrong. Either your work is wrong or you graphed wrong. You need numbers, and you need arrows, and an X and a Y. Ooh, careful. Those who have finished this graph, what's different about this graph than the first graph we did?
This one's upside down.
Why do you think it's upside down? Because the multiplier in the A position is a negative, exactly. Also, look at the vertex. It has been shifted. Because we had shiftings. We had a horizontal shift and a vertical shift. So it went, even though it says -3, we think opposite, and it went right 3. +1, we think same, and it goes up 1 from the origin. Okay, so for the remainder of class, we're going to be working on this. I'll give you some graph paper, because you're going to be doing some graphing. Yep. Okay, so the assignment's actually what I have right there on the board. Page 336, 1 through 16, and 18 through 20. Essentially, it's 1 through 20, and we're not doing number 17. Skipping number 17. Okay, so we'll pass out graph paper. Everyone will probably want to take 2 pieces. This is a graph.